Okay, so now there's time for discussions. Does anybody have questions for the keynote speakers? Yes, over there.
Thank you very much for very inspiring talk. My name is Kentaro Yoshimura, a chief researcher from Hitachi industry. My question is about how to, my expertise is safety critical systems, for example, automotives or power plants, such as some kind like that. And my question is about how to accept and review the result of test automation by LLM. Because, as you may know, some domain, for example, automotive domain standard requires domain expert should review and accept test result in the test process. I believe test automation in very near future, most of test activity will be automated by LLM. However, reviewing and accept by domain expert will be a bottleneck. Of whole testing process. I think we need to redefine testing process. For example, we trust software testing, and domain expert will focus into system testing, or we will develop domain specific review AI agent or something like that. If you have some insight or idea for this topic, I'm happy to hear your opinion.
Lionel, would you mind moving to the microphone? Thank you.
Yeah, you said many things, so I'm not too sure what you expect from me, but in safety critical domains, as you know, and I've mentioned that in my talk, one important aspect is traceability. That is to have proper requirements and demonstrate that your system complies with requirements, including safety requirements, for example. And I think that LLMs first can be used to improve requirements or do requirements quality assurance, and it can be used to help derive test scenarios from requirements in a traceable manner. As you have seen, I presented a project where we did that in an automotive context, but we use advanced NLP, but that was just before the advent of usable LLMs. And we obtained very good results, which actually may not be obtainable with LLMs even now. Actually, that's something to be demonstrated, but that is worth investigating. The problem also with many of those safety critical domains is that I'm not sure to which extent LLMs are trained on them. So probably that means that you need a lot of data and fine-tuning to make them usable in those domains. So is there any other point you want me to address? I don't know. I tried. Yes. Any other comment?
Baishakhi, do you have anything to add?
So I mean, I agree with everything what Lionel said. Just want to add one more thing. The more complex the domain and task is, it is probably better to reason about it. So decompose your task and then plan out, and then so it's like reasoning, planning, and solving and feedback. So usually for complex tasks, it is seem fruitful. So that is another thing. I mean, probably is good to try.
Okay, thank you. I saw Satish there and Jack in the front.
So, sorry. So I'm first. So, okay. So, many thanks for the interesting talk. So, as you know, the categorical problem is I think, is the hardest problem in software testing. And in the past, I think most of our technology try to avoid the Oracle problem like fuzzing and random test and many other technologies, even Overshoot. So my question is, with LLM, is it possible for us to solve the test Oracle problem? For example, when we give any test input, we can ask the large language model to read the source code, or if we have some requirements, and we can infer the Oracle, and then we run the source code to get the output, then we can make the comparison to solve the Oracle problem. Thank you.
Actually, I've addressed that problem in my talk. I don't believe that in most cases, LLMs can address the test Oracle problem by themselves. And at least in a reliable way, in a way that you can rely on. Because of course, again, if you get the Oracle right 60% of the time, that's not going to help you, you know. So, and if you have no way to determine which Oracle is correct, you cannot, because you would need the Oracle for that. So that doesn't solve the problem. I think we need to combine LLMs with other approaches. To me, at this point, but of course things can change in the future, combining LLMs with metamorphic testing is probably the best avenue for Oracle automation, I think. But how to do that is not obvious, actually.
Okay, hi, this is Satish Chandra. I have a question for Baishakhi. So, excellent talk, thank you. If I understand your technique correctly, you create paths using some symbolic analysis, and in the prompt you pass along a natural language description of that specific path, and then it creates a test that exercises that one scenario through the focal method, and then you have to repeat the process to grab different paths and so on. Have you...
Yes, yeah.
Okay, so the question, so then I understand it correctly. So the question is, have you actually tried to get an LLM to also enumerate these paths, and did it work or not, or did it not work? Can you share?
Right. We tried that. So we tried that, and they also work very well. In fact, I think both of this symbolic execution-based approach and LLM-based approach to infer the branch conditions, they are kind of complementary, because when we are asking, say, GPT-4 about branch condition, it also gives some more contextual information that symbolic executions do not have. So I absolutely, and the results are also kind of equivalent and complementary. We did not report that because it was costly to perform large-scale experiments. But it's a very valid question, and I mean, in our limited experiments, they were complementary.
Thank you. Jack, please go ahead.
Hi, Jack Zamindian from York University. So I have a question actually for both presenters. So it seems like one of the problems with LLM as it is it's trained on natural language. So it doesn't really understand code, right? And because of that, then we have to add in context to help them understand code and do different tasks. But throughout your talk, I see that different ways of adding additional correlate context, like during pre-training, during prompting, maybe even fine-tuning and so on. So I'm wondering, do you have any best practices or maybe even guidance in terms of under what task is more optimal or better to kind of put context in what kind of fashion?
Should I start, or do you want to start? No, anyway. Actually, I've addressed that in my talk, and I believe that there isn't a general answer. There are problems for which it's relatively affordable to find the type of data you need for fine-tuning, and there are problems for which it's not. And if data is hard to come by, the proper data. You have seen the example in my talk about collecting data about broken test cases, for example. And I mean, it doesn't come for free, you know. Then you have to use smaller models. Then you have to use smaller context. I mean, you know, you have to do more prioritization. Fine-tuning might not even be affordable, really. You know, so prompting, of course, is going to work more or less well, depending on the domain. I mean, the point is that for each testing problem in each context, we have to investigate what are the better trade-offs. There is no general answer. I think it's part of the research that is required. So a lot of empirical research is going to be needed to get answers for each testing problem. You know. Basically,
So yeah, I mean,
sorry. Go ahead.
sorry, Lionel, go ahead. I thought you finished.
Go ahead.
Yeah, I really like the way Lionel said. So cost is a big factor in your environment. So prompting also is very costly, right? Especially if you are questioning these open source, like querying these GPT-4 or larger models. So fine tuning has one-time cost, while prompting incurs that cost over multiple queries. So you have to decide in your scenario which is cost effective.
Yes, I think that's one issue in all of the research, is that researchers tend to underestimate or overlook cost and scalability issues. So it's not enough for a solution to be technically doable. It needs to be practically doable. You know, and of course, what's practically doable is going to vary from context to context, but nevertheless, you need to take that into account. You know, that's why those huge models can be used for everything, everywhere. You know.
Okay, thank you. Any other questions? Yes, go ahead.
Hi. So thank you for the talks. Very interesting insights. My question. So before I ask my question, some context. We've been working with some people, software testers and developers in industry, and we look at how they use chatbots powered by LLMs and why they either keep using it or stop using it at some point. And what we noticed is that whenever a software tester realized that the effort that they need to prompt or use the LLM is similar to the effort they would put in order to create the test case, then they stop using it because they have more trust and confidence in themselves more than the LLM, right? So reflecting on your talks, I see that like whenever we want to use LLMs to in a good way in order to ensure a good quality, we need to provide very specific prompts, provide a lot of context, and even with that, we may not even get a very good result, right? So my question, should we motivate software testers to use LLMs for example, test generation or test repair? And if so, how should we motivate them?
You want to start?
I will go. Lionel, I cannot hear you. Yeah.
Sorry. No, I was asking if you wanted to start this time. Well, it's okay, I'll start.
Oh, okay. You start, please. Yeah, I'll.
Okay. Yes, that's a very good question. That's why I said at the end of my talk that we need more user studies. But for user studies, at least as academic researchers, we need collaborations with industry that enable such user studies. We don't want to do that with students on little problems because we won't really get results that are representative or generalizable if we do that. It's a very good question whether it's always, like everything in software engineering, is a matter of cost benefit. So, you know, if you spend a lot of time writing prompts and in the end you get imperfect results, You know, you get code bleu, whatever that means, similarity of 70% and whatever. Then the question is that, okay, well, is it worth it, you know? And of course, there is no general answer for that. But I would say that there are problems for which there are not that many alternatives to LLMs. For example, you know, I had a project I've just shown on test minimization. Minimization techniques that exist don't scale. And minimization is a practical problem. And apparently, LLMs help, you know, at least increase scalability. I mean, there is always a limit, but, you know. And there are a number of problems for which, in fact, there are not that many good alternatives. And in which purely manual alternatives are not really workable either. So, but you're right. Right now, we don't have the empirical data and the empirical results to be able to motivate with a high level of certainty people to use LLMs for testing problems. And that's why more research is needed. That's why we need to do the research we are presenting, both of us. Yeah. And your research as well.
So yeah, I would like to add that empirically, people have shown, I mean, including us, that say for unit test case generation problem, developers often feel very lazy and they don't write unit test cases. So in general, I think in the paper or somewhere, I mean, I found like only 28% methods in a code is have unit test cases. So I think any kind of automation, LLM or not, also add that thing, like in many very repetitive, apparent obvious tasks, human tend to ignore it, and then, you know, big vulnerability or disaster come. I think there also again, automation, some hybrid automation can greatly help us to for the testers. Now, whether we completely rely on these automations or it will be in the like LLM in the loop fashion, I think we need a lot of research for doing that.
Thank you. Any other questions? Yeah, Gustavo, please go ahead.
Hi, hello, nice talk. I'm Gustavo from Huawei. I'm interested in your Flaky test project. So if I understand it correctly, you were basically searching for problems in the test code, right? But I would argue that flakiness can be very tricky when it happens in other places. So maybe, you know, in your Docker file, or even worse, sometimes it's in the test environment. You don't change anything, and then 30 days later, things start breaking, and you don't know why. Yes. So, yeah, so I was just wondering if you...
You're right. We focused on test code because apparently that was an important source according to studies of flakiness. But obviously, that's not the only one. The problem when the source of flakiness is in the system under test is that you have a scalability issue.
Okay.
You know, you are not going to pass as context the entire system.
Yeah.
You might not even have the source code of many components.
Exactly.
So that means you need other techniques in order to narrow down, to zero on the relevant part.
Right.
How to do that is a question. But you need a way to narrow down the context. You're not going to pass the entire system as context. You know. But you are right, there are many sources of flakiness, and each different source is going to require a different solution, basically.
Thank you.
Okay, any other questions? No? So, yes? Okay, last question over there.
Hi, I'm Hong-Ling, a PhD student at Kyushu University. I have a question for Professor Ray. Things you mentioned, if the LLM can really understand code semantics, it is a quite naive question. Do you think we can use like causal inference tools or any causal representing paradigm to improve LLM's ability to further understand the code semantic by capture the invariant representation of code?
So, sorry, I could not hear it. I mean, is it the question that whether we can use some code properties to improve the LLM itself? Is it the question?
Yes.
Yes, yeah, I think I mean, majority of my research is dedicated towards that. I covered prompting. So we are seeing like at different level, if you are say, for example, if you incorporate execution in your model training, it overall improves many software engineering tasks like bug detection, clone detection, even generation task as well. So, and there are other papers also that are showing, I mean, that are recently coming up showing that code does not, the models do not understand execution. So we need more execution aware models, etc. So I think that is a very interesting and, I mean, interesting research area, I mean, to carry forward.
Thank you very much. So that concludes the keynote session. So let's thank the speakers again.